The following video will introduce you to ANSYS component in VisualDOC, which allows direct interface to ANSYS Workbench. In this demo, I will solve a simple design optimization problem with analysis performed by ANSYS Workbench APDL solver. The figure shows the pallet lifter structure. The loading condition for this problem is that the two pallet arms are subjected to pressure load and the steel hinge and steel cylinder are fixed. The corresponding stress and displacement are calculated by ANSYS Workbench Mechanical APDL solver. Here, the objective function is to minimize the total mass of the pallet lifter. It is subjected to constraints. Stress should be less than or equal to 20,000 psi and the displacement should be less than or equal to 0.1 inches. The design variables are the thickness of all the components except steel hinge and steel cylinder. The lower bound for all the design variables is 0.1875 and the upper bound is 0.75. This example is for demonstration. VisualDOC has a capability to solve extremely complex optimization problems. Now the first step is the parameterization in ANSYS Workbench. For this problem, in order to pass the design variables, resultant stress and displacement to VisualDOC, it needs to be parameterized. Now open the ANSYS Workbench. A static structural solution has already been set up. I have already parameterized the design variables and results. Double-click on the parameter set in the flowchart and check whether all required parameters are defined or not. Now let's open VisualDOC. Now click on New Project. I'm saving the VisualDOC model in the same location where I have saved the ANSYS analysis file. The next step is to create workflow. From component palette, add optimization component. Select the ANSYS component and place it inside optimization component as this component is used to define the analysis needed. Now add a stop block. Now click on the flowchart components in the model tree panel and click on Auto Connect All Models icon. This would connect all the components based on their order in the model tree. Now click on Automatically Rearrange All Models icon. Now the next step is to set up ANSYS component. Go to Component Editor tab. Select ANSYS component from Model Tree panel. In the panel on the right, for the run location, make sure that Analysis Runs Locally radio button is selected. In the Analysis Working Directory, make sure that Use Model Directory option is selected. Under Local Analysis Program Definition, select Absolute for file part type. Now click on the file icon and select the executable file for ANSYS Workbench program, which is located under Installation path. For Windows and Linux systems, the executable file names are as shown in the slide. In project file definition, make sure that Relative to Model Directory radio button is selected. Click on the file icon and select your ANSYS Workbench analysis file. Push the Load Data button. Use Load Data button only when you want to load a new ANSYS Workbench file or if you have modified the name, the input-output parameters or the number of parameters defined in the ANSYS Workbench. In Parsed Input Data section, select the input parameters which you want to use in the optimization. Click on the checkbox corresponding to parameters in the Use column. Similarly, select the output parameters in Parsed Output Data section. VisualDOC provides a feature to select all parameters at once. The Select All Input or Output Data icon will only be activated when you select one of the rows in the data table and the parameters in that table are not selected. You can also deselect all the parameters by clicking on deselect all input or output data icon. Now push the test button. VisualDOC will launch the simulation. It is very important to test the ANSYS component to ensure the interaction between ANSYS and VisualDOC. After successful execution, you will get a message in Standard Messages tab. Next step is to create data transfer needed for the optimization component. Go to Data Linker tab. Select Optimization in Model Tree panel. Select Optimization in middle panel. Make sure that Auto Link checkbox is selected. Now click on Automatically Add Data to Selected Model icon. This would add the corresponding links for the data transfer. Now go to Component Editor tab. Select Optimization component from the Model Tree panel. I will be deleting one of the parameters from each symmetric part to maintain the symmetry of the structure. Only one parameter will be used in VisualDOC for each symmetric part. Now go to Data Linker tab. Select Add Link in drag and drop mode. Now, manually connect the main cylinder back thickness under Optimization in the left frame to main cylinder front thickness under ANSYS in the right frame by dragging the line starting at main cylinder back thickness and dropping at the main cylinder front thickness. Similarly, I will manually connect all other parameters under Optimization in the left frame to the parameters under ANSYS in the right frame. Next, I will set up the optimization component. Go to Component Editor tab. Select Optimization in Model Tree panel. For the data total mass, select the checkbox in the Objective column. Deselect the checkbox under Constraint column. Make sure that Minimize option is selected under Goal column. For the input variables, lower bound is 0.1875 and upper bound is 0.75. For maximum displacement, the upper bound is 0.1. For maximum stress, upper bound is 20,000. I will be using modified method of feasible direction, which is default gradient based optimization method in VisualDOC. Now change the relative finite difference step size to 0.005. VisualDOC has a capability of batch processing of design points. Instead of generating one set of points, the design component can now generate more than one set of points at once and can pass all the samples to the subflow at once. The components in the subflow are capable of processing the batch of points either sequentially or simultaneously. Transferring and processing data in batches reduces the total execution time. Now go to Workflow tab. Right-click on Optimization component. Select the checkbox Transfer multiple samples at once. Now I will create two simulation monitors to monitor the best objective and the worst constraint violation. Go to Simulation Monitors tab. Add two optimization history monitors. Now click on the Expand Hierarchy icon below the Flowchart Components panel as well as List of Monitors panel. Drag the best objective under simulation parameters and drop it on the x1 axis of the first monitor. Similarly, drag the worst constraint under simulation parameters and drop it on the x1 axis of the second monitor. To activate the defined monitors, click on Enable All Monitors icon. Now click on Validate icon. Our complete model is valid. Before running the model, make sure that ANSYS Workbench is closed. Now click on Run icon. To view the defined monitors, go to View Monitors tab in the message area. For both optimization history monitors, x-axis represents number of iterations. The total number of iterations are 12. For the first optimization history monitor, y-axis represents best objective value for each iteration. For second monitor, y-axis represents worst constraint violation value for each iteration. It can be seen from the graph that there is a constraint violation during the process. To check which constraints are violated, go to Post-Processing tab. Now select Optimization from Model Tree panel. Now click on Generate Summary Report icon. Scroll down to iteration 12. It can be seen that the displacement constraint is violated, but it is within the tolerance, so can be neglected. To view the optimum results, go to Component Editor tab. Select Optimization in Model Tree panel. The table displayed in the middle panel has the optimum values in the optimum column. The optimum value for total mass is 6.19 pounds. The total mass is reduced by approximately 33%. The table displays the initial and optimum values of total mass, maximum displacement, maximum stress, and design variables. This completes the demo. I hope that it has helped you to get familiar with ANSYS component and batch processing in VisualDOC. If you would like to learn more, I invite you to check other videos about VisualDOC. For more information, please visit our website at www.vrand.com or email us at visualdoc.support@vrand.com. Thanks for watching.